Well, why are we doing this? I mean, I mentioned that we've been doing this for a couple of years, and we've been doing it face-to-face. Well, one of the things about face-to-face is that it costs a lot of money. And we don't have a lot of money either in the university or in the SAF. So we're looking to try and be as cost-effective as possible. And the webinar approach seemed to be a pretty good way to try to disseminate information that's relevant to this issue. Forest management is happening everywhere. Fuels treatments can have adverse effects on habitat and wildlife. So, you know, we've got the FRAP report, which was recently published, has got abundant evidence of increased fire frequency, size, and intensity, and predicted further increases in the future. Numerous communities are at risk from wildfire. This is the Angora burn. The coloration here is predicted fire severity before the fire, and actually if you looked at what happened after the fire, it pretty much conformed to what the modeled predicted severity was. What you're looking at here is the red indicates areas susceptible to crown fires, you know, and so we've got large areas of the state which could be subject to stand replacing fires. We've also got lots of places that have already burned, and there's thousands of acres that are in need of treatment, post-fire restoration. We don't want to create more of those, so we're implementing fuels treatments because we expect to have benefits by trying to reduce the wildfire impacts on natural areas and on communities. But we have to have balanced objectives when we're looking at these treatments. We want to not just reduce the risk of wildfire. We want to try to improve forest health and productivity. We want to reduce the risk of disease and insect attack which tends to be associated with stands that are susceptible to wildfire. We want to minimize direct and indirect impacts on wildlife and native plants, and if possible, we want to improve wildlife habitat. So we can have multiple objectives through the vehicle of fuels treatments, because fuels treatments are just forest management. Now, I don't want to bore you too much with, you know, the process that all of us have to go through, but I do want to indicate that there has to be a process for fuels treatment, and the process has to begin with knowledge of the resource. You know, what are we dealing with, and how are we going to deal with it in a multiple objective format? What are our alternatives? How do we evaluate those alternatives, and then monitoring the results? And many of you, I'm sure, are involved in this process or in various parts of the process. Wayne Spencer has joined us, and you know, he's a scientist who's involved in monitoring what happens during fuels treatments. Others of us are involved in the implementation, actually doing it on the ground. But we have to think of this as the context of a process, and the process occurs not just at the project level, but at the landscape level. So where and when do regulations apply? And we're not going to go into this in any detail, but we just, you know, want to suggest that fuels treatments, like any other forest management activity, are subject to regulatory requirements. And if they're commercial harvests on private land, they're subject to the Forest Practice Act. If there's state or federal funding involved, then it invokes regulatory requirements. If there's sensitive biological resources, other land use entitlements, if there's projects that involve land development, and sometimes you'll see, for example, on subdivisions, there are requirements for fuels treatments to reduce fuel loads before the subdivision can be approved. So there's some examples of projects that are subject to regulatory requirements. Prop 40 projects that are funded by CAL FIRE, EQIP projects that are funded by NRCS, anything happening on federal lands, any activities affecting T&E species, and activities within stream channels or wetlands. So the key considerations, if you want to attempt to minimize the regulatory impacts on your projects, are to try to avoid sensitive resources rather than try to mitigate the impacts. Mitigate means cut off because you know something's going to happen. If you can avoid, that's another form of mitigation which is far superior in my view. So, but to avoid, you need to know where things are. So where is the sensitive species? Where are the resources that have to be known about? Timing can be just as important as where the treatments occur, and Lorna will emphasize this, I think, in her presentation. We're planning things at the project scale in areas like this or wherever they are, but we need to view them in a landscape context and what we can do on our properties or what we can do on properties through the vehicle of, say, a community wildfire protection plan depends on what's around us. And this also applies to habitat considerations at the landscape scale. If we're dealing with areas like this versus areas like that versus areas like that, then they all have different implications in terms of habitat. I'll pause now and see if anybody's got any questions, and then I just really want to just put us all on the same page relative to what we're talking about in terms of fuels treatments. Joe's asking if slides will be available afterwards, and yes, they'll be posted at the website. The entire presentation, the recorded presentation, will be available at the website. Everybody caught up? Neville's asking about San Diego County. Well, but Neville, what we were looking at there was forest fire situations and susceptibility to crown fire. Okay, in San Diego, we're talking mainly about, lower stature vegetation, and so you wouldn't see it on there. If you were looking at instead at a fire severity map of San Diego County, you would see a lot of red. Okay, I'm going to move on a little bit here. Just a little bit of background on me and where I'm coming from on this. I've spent quite a bit of time, not just in education on this, but actually in the practical applications, primarily working in Placer County on fuel management guidelines for their conservation reserves. And in looking at conservation reserves, which in this case are required for the conservation of listed species, listed wildlife and plant species. That's why they're required. There's two issues there. One is you want to manage them to conserve the species, and you don't want the habitat to go up in smoke. Beyond that, you also have the issue that conservation reserves may be nested within areas of private land. You don't want a fire starting on a conservation reserve spreading to a private property. So we, as part of the pending draft HCP, NCCP for Placer County, Western Placer County, I developed a fuel management guidelines for conservation reserves that they have and that they also will be acquiring. So that's part of where I'm coming from. Also, we do a lot of teaching on this, and issues such as defensible space always come to the fore. So, we're dealing with shaded fuel breaks, defensible space, general forest treatments, and then the special conditions of riparian zones and wetlands, and that's what I want to talk about. These are where the treatments are occurring. So fuel breaks, we more or less know what they are, I think. Shaded fuel breaks are kind of in vogue, as opposed to completely open, cleared fuel breaks, which were common, especially in Southern California in the past. This is Angora, fuel break next to a neighborhood in Angora that actually was effective in protecting a neighborhood. This is a fuel break in Oak Woodland on a conservation reserve parkland in Placer County. Here is a fuel break, if you will, in a plantation. The goals of fuel breaks are to interrupt fire spread, change behavior, and provide a staging area to fight the fire. It's really critical to understand that a firefighter views these as places where they can make a stand. So, you have to interrupt the behavior of the fire in order for them to be able to make that stand. Fuel break positioning, this is Grizzly Flat, El Dorado County, encircling and defending the neighborhood along ridge lines and roads and at land use boundaries. The width of these things varies from 100 feet, 200 feet on either side of a ridge or a break and slope, maybe up to a quarter mile. Some guidelines for fuel break that we're trying to encourage, where it's consistent with safety concerns, retain snacks, particularly large ones. And I'm sure we'll have some discussion about this as we go along through this series. Avoid the introduction of exotic plants, particularly hitchhikers on equipment. If a piece of equipment has been working someplace clearing exotic plants and then comes unwashed or uncleaned to your site, it could introduce those plants to your site. Where feasible, allow patches of shrub cover and smaller trees to remain and separate these from each other and from tree canopy. Consider future stand conditions and composition when you're marking trees to remove. In other words, removing an entire cohort of species from a stand is not only going to reduce wildlife habitat values, it's also going to determine what the future stand conditions are. So you need to consider that if you want to maintain particular species in your stand. Defensible space, some of you are probably involved in implementing that. The goals are to reduce the probability of house ignition and create a safe area for firefighters to work, the before and after. Now, more and more, we come to understand that the condition of the house and susceptibility of the house, the flammability of the house, may be equally important to the vegetation. I've seen lots of pictures of house-to-house ignitions with vegetation remaining. We even saw that in Angora. A lot of the ignitions in Angora, on the Angora fire in the Tahoe Basin, were house-to-house. Guidelines for defensible space. There's a great handbook that's on the Board of Forestry website that provides some guidelines for creating defensible space. Total clearing is neither necessary nor desirable. And in wildland areas, you'd want to try to avoid planting exotic plants. Consider wildlife enhancements. I mean, lots of things can be done right around your house to try to enhance wildlife habitat values. We're not going to talk much about defensible space. I mean, that's certainly a regulated area, and we're primarily concentrating on project level and landscape level treatments. So we have general forest treatments too, and these are pictures from studies that Mike Taylor-So has been doing. The goal for these general forest treatments is to reduce the likelihood of crown fire under moderate weather conditions, and this often involves thinning from below to reduce the density in the overstock stands. Most of the people that I know would tend to agree that overstocking, particularly in mixed conifer stands, is a main reason why we have high probability of severe fires. So, that's what we're trying to do there, is to reduce the understory commonly includes a reduction in surface fuels through the use of masticators, if it's level ground, and or prescribed fire, broadcast burn, pile and burn. So you can see when you change this to this, there's going to be obvious changes in habitat. Is there something in between these two which represents a balancing of objectives? Here's another one. Thinning in young, mature stands can reduce the fire hazard, and it can also improve forest health and increase tree growth. So you can achieve increases in productivity, and you can reduce susceptibility to disease and insect attack. But overly zealous general forest treatments can have adverse impacts on habitat, mainly by removing structural elements and by removing entire size classes and species. Potential impacts include removal of critical habitat components, snags, hardwoods, shrubs, simplification of stand structure, turning a multi-storied stand into a single-storied stand. Maybe impairment of understory regeneration because the land gets worked over by machinery and gets compacted. You might have overly deep piles of chips from mastication, and you get wildlife displacement and mortality. There's some guidelines that, again, we sort of generally try to promote, implementing what we would call a variable thinning regime, creating a mosaic of different stand ages and densities, avoiding diameter limit thinning. In other words, prescriptions that say take everything out under 8 inches, are to be avoided because you want to try to maintain a mosaic of stand ages and densities if possible. They need to be separated from each other, but that's not impossible. Retain all the habitat components while reducing the fuel's connectivity. It's the connectivity you're trying to interrupt. You don't want fires to spread from one habitat component to another. And then time treatments to avoid impacts on sensitive species. And again, Lorna will talk a lot about that in our next presentation. For riparian zones and wetlands, my research over decades really has been on riparian functions. And I know right after the Angora fire, and we're looking here at Angora Creek, there was quite a stir about the Angora overstocking in the Angora riparian zone contributing to the spread of that fire. One would have to take a look at what the weather conditions were in that fire to really sort of understand why it got so far so fast. But I can tell you one thing, the groundwater conditions along Angora Creek were such that a lot of the riparian zone along Angora Creek consisted of lodgepole pines, as opposed to the more the species that have more higher moisture content, such as willows and alders and such. So if you look at this slide over here, you can see this is a very severe fire. And where do we have vegetation left? Along the stream valleys. Okay? So I think most of us who have been looking at these over many years would say that riparian zones aren't especially prone to wildfire, severe fire, under moderate weather conditions unless they've been degraded. They've been invaded by upland species or exotics, tree of heaven or, giant reed or some of these other species that are more flammable than the natural riparian species. Or the streams have been affected by reduced flows in groundwater, so they're drier than they would have been naturally, and so they're more susceptible to wildfire. Generally, when a fire comes into a riparian zone, it has a patchy impact. It doesn't result in a stand replacement. So for riparian zones, the general guidelines, avoid the bed and banks of streams. Not only will you avoid impacting the stream in the riparian zone, you'll avoid invoking the wrath of the Department of Fish and Game. and 1603 permits. Provide buffers and focus the treatment at the interface between the riparian wetland areas and the uplands. In other words, this is where the fire is probably going to come this way. And if you can interrupt the spread of the fire into the riparian zone by treating that interface, reducing fuels in that interface, then that's a good thing in my view. Then you can go inside the riparian zone and thin to reduce ladder fuels, but try to maintain habitat diversity. Again, recall that if the site is occupied by the natural riparian community, it's going to be higher in moisture content and it's going to retain more moisture later into the season than in an upland condition. So some conclusions of my talk, and again, I'm just trying to set the stage for all the things that are going to follow. Forest management can achieve forest health and risk reduction while minimizing impacts. You have to have inventory information. Got to know what's out there, not just what the fuel loads are, but what the species are and what kinds of habitats they're occupying. One size fits all doesn't do the job. It may be easy to implement or to explain, but the results aren't necessarily going to achieve multiple objectives. And your treatments do need to address long-term stand conditions. That concludes my presentation, so I can take a few questions now, and then we'll move on to Lorna.
And then my contact information is going to appear at the conclusion of the presentation. First, let's start with some history of our present-day regulatory environment for wildlife. Here in the U.S., wildlife is a trust resource for all people. No one can own wildlife. It may be taken with a license or a permit, but the people as a whole own the wildlife resources in this state, something most of us know already. When fur traders, gold miners, and railroad workers came to settle here, California was thought to have an inexhaustible supply of wildlife to consume for both meat and clothing. We were in an era of abundance. Then, as fur trappers intensified their hunting efforts, and no longer were waterfowl flocks large as clouds seen across the Pacific Flyway, and the grizzly bear portrayed on our state flag became extinct, the legislature was starting to be concerned. We had entered an era of exploitation, so they started making laws to conserve wildlife resources. And that's where we are today. We're in the midst of the era of regulation. We're discovering that regulations are helpful in protecting some species, but on the other hand, they become quite burdensome. Because California has a lot of people to govern and a deliciously complex landscape, a one-size-fits-all regulatory framework doesn't work very well with respect to wildlife. If you're a hunter or a fisherman, you know that there are specific rules for each deer zone and each stretch of water in this state. Are these laws actually protecting California's wildlife resources? We know very little about more common species distribution and abundance. All we can do is speculate that it would be a lot worse if we didn't have laws that protect wildlife. History bears this out. Maybe some of you have participated in bird nest searches or bat surveys or red-legged frog surveys. If you have, you know they're time-consuming and thus expensive. So we don't necessarily know if the regulatory framework is actually working across the entire suite of species found in forests and woodlands. Those we do study, like spotted owls and deer, are generally in decline. We need some better ideas about how to manage the state's wildlife. I'll be talking about some of those ideas later. Many years ago, I used to wonder what happened to wildlife in fires. You always hear about a bear or a fawn rescued from a fire with burns or other injuries. Fatalities do indeed occur, especially in high-severity fires or those requiring backburns that protect homes and structures. They corral wildlife, preventing their escape. But you might be surprised to discover that wildlife can survive natural wildland fire fairly well. In cases where fires are not moving at speeds that overwhelm them, wildlife can move away, move to water, or move underground. Taking human-caused ignitions out of the picture, lightning-caused fires generally occur in the summer season. And they are when the vegetation is dry enough to burn. By that time, most young animals have the ability to flee, take refuge from an oncoming fire that has a low rate of spread. Native vegetation has set seed, and they actually have some advantage the following spring should a fire occur during the summer or fall. The two greatest causes of direct wildlife mortality are fires that occur during the breeding season and fast-moving fires that animals can't get away from. If the extent of the habitat change resulting from the fire reduces forage and protective cover, wildlife are vulnerable to starvation and predation over time. That's the mortality we don't generally see, and scavengers are quite efficient at keeping the forest floor clean. If there's sufficient habitat remaining, wildlife can survive until rains come again, and nutritious new vegetation carpets the burn area. Okay, so how are fuel treatments different than wildfires? Well, they're quite a bit different, and there's some research that bears this out. Either funding windows or other factors can require the project implementation to occur during the spring breeding and blooming periods. Wildlife and plants are in their vulnerable breeding season and blooming season with complete focus on raising young or setting seed. Also, diameter limitations that fuels projects are under, and ladder fuels removal, canopy spacing, they can have a plantation effect, and the result is shaded fuel breaks in particular. Cover, tree species variability, and food supplies can be limiting for wildlife and fuels treatments. Taking out snags, especially large snags, removes potential shelter, food supplies, and nesting and denning sites. And generally, if snags do remain on a fuels project, they're cleared of surrounding vegetation. Ladder fuels in fire speak, perching and screening trees in wildlife speak. Wildlife choose nesting and denning sites based on their availability and adjacent cover to protect young from predation in the elements. A lone snag may not provide the cover needed by a particular species. Fire removes ladder fuels such as shrubs and other forest debris with varying intensity depending on the fire behavior. For an entire suite of species, shrubs provide forage and cover, two of the three elements necessary for wildlife survival. They provide refugia for prey animals, and in most fuels treatments, shrubs are the main target for removal. In fuels treatments, fires are most often concentrated into piles rather than broadcast through the forest. This is done to prevent escape, but the soil underneath the piles is often sterilized, preventing plant materials from revegetating, and the surrounding duff and litter are generally not removed, suppressing vegetative growth of grasses and forbs, again limiting forage resources for wildlife. How does wildlife respond to fuel treatments? Well, we don't really know. As I just described how fuel treatment effects are different than fire effects, research about how wildlife occurrence and distribution patterns is only recently taking place. Pat Manley, a biologist with the Pacific Southwest Research Station, explains that fuel treatments do not mimic a serial progression like even age management, but are also not designed to maintain the full breadth of old forest characteristics. so they present a unique constellation of habitat conditions. Some of the presenters later in the series will give you some of the latest finding of current research projects, so we're beginning to get some of the data gaps filled in. But we don't have good predictor models other than the California Habitat-Wildlife Relationships model. And it's kind of a long story if you want to know what that is, but it's a model that predicts whether habitats are suitable for a whole suite of California's wildlife species. CWHR was developed to model vegetation characteristics that follow the serial stage progression. Fuels treatments do not follow that progression. Dr. Manley did some research to compare the results of CWHR modeling with actual on-the-ground measurements of wildlife richness and abundance. She found that the model failed to reflect the number of species losses while the stand size and stage classifications remain the same. In other words, the model doesn't model fuels treatments very well. Cal Fire biologist Bob Matroni and I also found challenges when we attempted to model fuels treatments using this model. It took some tweaking to get the results that made sense, but that's still the best we have for now. Most often, we use best professional judgment when evaluating project impacts. And it's difficult to make those judgments when you have no survey information. With limited funding available to implement fuels projects, it's difficult to divert scarce dollars to find out what wildlife is using a project site. But it's important, and it may be more important than we think in 10 to 20 years. On private lands, unless sensitive species are documented, there's no way to know what might be there. We guesstimate based on knowledge of the habitat types and other element species needs for survival, and then determine if that habitat is suitable to support that species or not. And little to no monitoring is done for species without conservation or game status. There's an awareness and desire to know wildlife presence or absence, particularly when it comes to those in decline, but it's darn tough and expensive to survey every project. Okay, so that's what we don't know. What we do know, to some extent, are general population trends for species with special conservation status. An example is the California Natural Diversity Database, more commonly known as CNDDB. Certain animals warrant conservation plans, like Fish and Wildlife Service conservation plans, and lands are increasingly set aside for protection. But putting a species on a list doesn't solve problems, it only makes us aware of them. Trying to protect scarce mobile creatures who are fearful of people in the first place is always challenging. Game species population trends are tracked so the department can know how much hunting pressure can be placed on a species without putting them on a list too. We know which rare plants we need to protect. The question is how, particularly on private lands. But even on public lands, I'm aware of an endangered plant where there's only 13 known occurrences in the entire state. It's on the decline due to the proximity to people who allow grasses to invade. The grasses make the people feel the need to weed whack the area. And even though there are obvious signs, like signs, real signs, describing this area as a place where an endangered plant lives, the whacking continues and the plants are struggling. It's a small and unobtrusive plant, and it actually dries out in the summer. It's not a charismatic spotted owl, but it might not be around much longer, and that's significant to people in this state. So with respect to plants, it's not which ones, but how do we effectively protect and nurture those that are having a hard time? With respect to research that's either finished or ongoing, the latest and the greatest is the GTR 220, an ecosystem management strategy for Sierra mixed conifer. It's fast becoming the go-to publication for new directions in fuel treatment designs, elements of which I'll be talking about later. The Plumas-Lassen administrative study, a somewhat long-term monitoring effort to study passerine birds, small mammals, and California spotted owl, provides an annual forum in which they present their findings. I think they're in their 8th year, Mike, right? Anyway, The tea kettle experiment, that was a 10-year study on the Sierra National Forest that covered a wide range of ecosystem monitoring, from soil to hydrology to flying squirrels. Those findings are available on the Forest Service's Tree Search website. And as I mentioned before, Dr. Manley's studies on fuel treatments and their impacts on wildlife in the Lake Tahoe Basin is also available. So what does this tell us to do? Generally, from a landscape perspective, the recommendation is basically to paint the landscape as fire would under low fire conditions. How would fire effectively weed your garden, you might say? At the project scale, consider how fire will behave with a specific set of project conditions: slope, aspect, general wind direction, and also consider the priority in your local fire planning documents, community wildfire protection plans, or CAL FIRE unit plans. There are scarce monies available today to do fuel treatments. We need to use public grant money to fund the highest priority areas to be the most effective in wildfire prevention. Oh, and I get to try this pointer thing. So at the landscape level, this is a diagram taken from GTR 220, and I thought I could get the pointer going. There we go. All right. At the landscape scale, and based on the expected fire behavior, plan and prioritize your treatments according to the arrangement of fuels, dominant wind direction, slope, and aspect. So up on the ridges, steep, dry slopes, ridges, treat those more aggressively, as fire would be expected to consume more fuels there. But down in the valleys, watercourses, meadows, north slopes, lower priority. Fire would expect to move slowly there and perhaps even die out. So design less intensive treatments there. Over here, these are all natural wildlife corridors and areas with the most protected cover. Again, at ridge tops, they have the lowest stem density and the highest percentage of pine in contrast to riparian areas. And then mid-slope forest density and composition varies with aspect. Density and fir composition increase on more northern aspects and flatter on slope angles. And on flatter slope angles. This is a picture of the Tahoe Donner community of 6,500 homeowners located in Nevada County. While this south-facing ridgetop wants to be a shrub field, treatments were designed to provide both a fuel break and still maintain the functionality of chaparral, providing wildlife forage and cover. This is a harsh, high-elevation environment. This fire break was tested a few years back when a fire broke out on Interstate 80. Oh, I got to get rid of this. Okay. The red arrow shows where the fire stopped, and you can see that conifer of various age classes provide additional habitat connectivity. So this is kind of an example of the balance that you might strike in your projects. And this is the opportunity. We're taking a break. I'll be talking about smaller size project scale next, and so we can take your questions now. Okay, Neville asked about how does wildlife and vegetation respond to lack of fire through effective firefighting. And that what you're talking about perhaps and maybe you can share with me, is, for instance, in wildland fire conditions, doing back burns to protect structures. Wildlife sometimes get lassoed into there.
Actually, I think, Lorna, what Neville is suggesting is how has habitat been modified through our effective suppression, and what has that done to habitat?
Well, management or no management is management, and certainly in California we do know that fire suppression has caused the weeds to grow, so to speak, in the garden, and so we don't grow a very good forest garden at the present time, and it's also a very fire-prone one.
So this might be an opportunity while we are pausing. Let's see, Lorna, you addressed a question to me in terms of the longevity of the Plymouth-Lassen Administrative Study, and yes, it's been going for actually 9 years now. And then there were concerns popping up in the chat box with the inability to toggle to full screen. I'm not sure what the issue is. The thought I have, if we could do it right now, is I could close out Lorna's window for a moment, bring it back, and see if that opportunity presents itself again. So I'm going to go ahead and do that. Lorna, just hold tight, and all the participants hold tight. It'll only take me a moment to close the window that she's presently presenting in and start it again. We'll see if that full screen option presents itself. So here it goes. Looks about the same to me. So we're getting questions being typed by Neville and Joe, and then I'd suggest that we proceed. Lorna, let's see what they're typing. I can't see it just yet. We're doing fine on time, by the way, Lorna. We've got 55 minutes more.
Great.
So Neville's question is, actually Joe's question is, no joy, in fact, full screen disappeared from all windows. So that's Joe. Hopefully it's come back. What I'm finding is that when I toggle when I roll my cursor over the window where Lorna's presentation is, that button becomes active. I don't know if you as a participant would have a similar experience, and then the option to toggle it or not. I refrain from using that because then I can't see the chat and monitor everything else that's going on my screen. So moving on, so Joe, let me know, keep me informed of your status with regard to the window and the screen. Neville asked the question, is wildfire or wildlife disadvantaged by fire suppression? And we need to know how treatment will improve the situation.
Well, wildlife as a whole, you can't put them in one box and say yes, they're advantaged or disadvantaged. There's a whole suite of species that exploit fire-suppressed environment. There's just a lot of fire-suppressed environment out there. As far as needing to know how to improve the situation, the idea is to find a balance of different habitat conditions, and that's what we're talking about here, is increasing the forest mosaic, increasing heterogeneity, and that will support the most diverse amount of wildlife species. Are we ready to go back?
Yes, go ahead and continue.
Okay.
Thanks, Neville, for the questions, and Joe, I hope you're able to correct your screen challenge there.
Okay, and I'm going to talk about this a little bit more now. Is we're moving to the project scale. And the conversations nowadays are less about diameter limits and more about diversity with respect to tree species, size, and vertical and horizontal arrangement all across the landscape. Think about how your project will revegetate itself once you've opened it up. What looks good when the project is completed can look vastly different in just a few years. Maintenance is a critical issue. I was just up in Georgetown not too long ago. I remember this forest treatment that the Forest Service did. Georgetown in El Dorado County is very prone to Scotch broom and invasions. And sure enough, in this project that was beautiful, say 4 or 5 years ago, the Scotch broom is way back and it loves it there. So think long term, as Richard has suggested before as well. So if a project is on a ridge top, expect that fires will burn with greater intensity. Think pines and increased spacing there. Valleys and wet areas can be of lower priority. Maybe you don't even want to do them at all if you have scarce dollars, and leave higher canopy closure there. On smaller projects, look over the surrounding landscape. See what habitat it currently provides and what your project can contribute in terms of special habitat characteristics. Identify a variety of tree types to be retained, with particular attention paid to hardwoods. Hardwoods provide unique forage, cover, and reproductive structures, and if you cut them down, they just sprout back into future ladder fuels. Think of a unique grouping of trees as one and provide greater clearance around that group. So the grouping and the gapping to provide the discontinuity to stop the fire. At the project scale, you're likely to find some special habitat characteristics that will improve habitat suitability for a number of wildlife species. Or if they're absent, you're dealing with a plantation or a very homogeneous landscape, you can create it in the long term. And we talk about large dead snags. These are ideal places for wildlife to hang out. And you also need to consider the trees around them that provide cover from predation and from thermal forces too, like weather. Deformed trees. Wildlife love them, foresters hate them. They're also great places for wildlife to hang out. So again, considering the trees around them as well. Large down logs. They're pretty generally easy to leave because they take a lot of time and energy to remove. And they are also the longest to dry out as the summer progresses. So they don't present the fire hazard that the smaller diameter splash and finer fuels do. Forest edge. Edge or a break in canopy cover provides landscape variability, kind of getting back to Neville's issue. Deer can use this meadow for forage. Rodents can use it for both forage and cover. Raptors can use the trees for perching while hunting. Deer can run into the forest if disturbed while grazing in the meadow. Forest edge increases heterogeneity and therefore wildlife diversity. Nests, dens, and burrows. Obvious signs of wildlife activity, and some wildlife return to these places year after year, so think about that. In prior presentations, I've put together this top 10 list of wildlife and plant considerations in fuel treatment projects, and I'm going to share that with you. And as you've heard before, I'm a proponent of operating outside the breeding and blooming season. So scope, survey, and assess and plan in the spring and summer months and do your work later in the fall. If you've worked in the woods in the spring, you've run into nests and young once in a while. I know I have. Young wildlife are very vulnerable to disturbance during this time. This is the season of birth. If you can, work in the fall or drier parts of the winter. I know it's hard, but if you can, that's great. Number 2, know the wildlife and plants in your project area, especially those with special conservation status, and you're required to in some instances. Include a variety of species on your project. Fuel reduction isn't fuel elimination, and a variety of trees and shrubs will increase the habitat suitability for a variety of species. Number 4, leave areas for wildlife corridor and connectedness. These corridors are often lacking in shaded fuel breaks. And this is a picture of a retired firefighter's front yard. And the Fire Safe Council and he both agree that this is actually very fire safe. It's north facing, and the shrub in the front is actually blackberry. And if you get closer to his house, he has great defensible space. So it's possible, and even firefighters are doing it. And as we said before, retain large snags and live trees with defects. Yes, they throw embers, and yes, they fall on structures or roads once in a while, so you have to consider where they're located and whether it's safe to leave them. Number 6, choose the least hazardous pesticides and herbicides. Last April, SNAP researchers discovered that 90% of Pacific fisher carcasses they tested showed exposure to rodenticide. That's pretty alarming. Some of us remember what DDT did to eggshells when birds ingested it. Use pest control advisors who know your area. The U.S. Forest Service also maintains a website that houses environmental fate determinations for a range of pesticides and herbicides, and it's a great resource. Here's the link. If you miss it, I can give it to you later as well. Number 7, check wood piles for wildlife. If your piles have been laying around a while, look for signs of wildlife. Kick the pile around a little bit, and then perhaps light it on one side to allow for escape. If you really want to be sure no animals are inside, you can start a new pile, yeah, and use the existing one to feed it. You can also leave the piles there if they don't present a hazard. The photo on the left, you can see that the pile has good clearance and lies within a treated area. Perhaps it could be left for shelter for wildlife. That's the call of the project manager. Learn your rare plants and protect them. Forest botanists are more than happy to discuss protection measures for rare plants if you have them. The Forest Service has botanists, and so does BLM. Your local chapter of the California Native Plant Society is also a terrific resource. Rare plant enthusiasts get very excited to discover new occurrences, so use those resources. In general, leave stream vegetation. Remove the upland vegetation, like Richard explained before. Consider that you might need a stream alteration agreement from the Department of Fish and Game. It's going to cost you some money and time, so think about that. If you alter the bed, bank, and channel of a stream or lake, you'll need to be talking to us. And last, but certainly not least, don't plant or introduce or spread invasive non-native plants. Mastication at the wrong time of the year, weed seeds traveling on equipment, clearing near existing weed infestations all offer opportunities for invasives to expand their range, especially when you just open up an area for them. The California Invasive Plant Council's website is a tremendous resource for minimizing and managing California's weeds. But unfortunately, the problem continues to grow. Great people, wildlife resources, CAL FIRE's foresters. CDF might have changed their acronym, but it's still the Department of Forestry. These folks have a wealth of knowledge about forest management and fire, and many have wildlife backgrounds as well. Give them a call, drop them an email. There are many knowledgeable foresters whose workloads aren't what they used to be. If you show a commitment to wildlife habitat enhancement, they can design a project for you. Forest Service biologists can give you a landscape perspective about wildlife in your area. And then the UC Extension foresters, some of whom are participating in this webposium series today. I'd like to say my department's available to help. I still am for now, but our timber program suffered the budget axe last year, so it's more difficult to find help. You kind of need to know where to find it. And then a resource that isn't used very often, longtime residents and wildlife enthusiasts. They know what's currently there, and a lot of times they know what used to be there as well. So we're entering another break. I'll be talking of my summary next, and let's have some questions.
Are there any questions any more questions, I should say, for Lorna? So Richard asked to see if everybody is on the question slide. If everybody is, and if there's no questions, then I would suggest that go ahead and go forward, Lorna.
Okay. Oh, Neville's typing. Neville asks, what is DBH? That's diameter at breast height of a tree. So what's the diameter of the tree? Sorry about that.
And breast height for the non-foresters among us is at 4.5 feet on the uphill side.
Versus, well, okay, so Neville seems to be a little bit confused about what has been going on in fuel reduction projects currently and what we're hoping to change in the future, perhaps, is that many of these projects have diameter limits. In other words, there's a maximum size tree that can be removed. Many of these projects are grant funded and cannot, by virtue of the program itself, generate revenue. There's always a concern about commercial logging in some of these fuels projects, and I believe that's where it came from. It's always been kind of a challenge for foresters to design effective projects by having a diameter limit. And so now there's this movement toward getting to a diverse landscape, increased heterogeneity. Perhaps you might need to take out a 24 to 36-inch tree. It might be good for the project itself. That's kind of what I'm talking about. Okay, are we ready to continue?
I'd say go ahead.
Okay, moving on. More about what we don't know. We don't know the cumulative impacts of projects that are initiated in the spring during the breeding and blooming periods. If anyone knows of studies on seasonality, I'd appreciate copies. Whenever I get excited about a new paper on fuels and wildlife, I'm disappointed to find that seasonality has not been considered. How to balance the need for flammable structured elements for wildlife snagged down wood with fire prevention strategies. Snags throw embers, down wood adds to the surface fuel layer. What's the best ratio for both fire and wildlife? How to address maintenance issues. How useful will these areas be to wildlife in 5, 10, 20 years if you remove all the smaller trees and shrub cover? And then how do we best manage riparian corridors? And Richard gave you a little bit of background on that. And other sensitive areas for fire prevention without decreasing the habitat value. We know that not managing them isn't the best strategy either. Again, what's the balance? So where do we go from here? This is what others say. Scott Stevens, a professor of fire sciences at UC Berkeley's Wildland Fire Science Lab, says, do not seek averages. And what he's talking about are average basal areas, average numbers of trees per acre. He wants variability put back into forest ecosystems. And Malcolm North of the Pacific Southwest Research Center, and he's the principal author of the GTR 220 publication, says, get fire back in where possible. Move carefully in areas with sensitive species, and institutionalize monitoring. It needs to be the watchdog. What I say is incorporate biological resource considerations into fire planning documents. You'll hear from Miriam Morrill a little later in the series about how Butte County has done just that. Other counties and some towns are working on that as well. Provide educational opportunities for forest workers and landowners about identifying sensitive species habitat, retaining special habitat elements, and encouraging treatments that mimic low-intensity fire conditions. More public-private research and cooperation for monitoring on the effects of wildlife and fuel treatments is really important, but that involves a lot of trust, and we still have a ways to go on that one. Report sensitive species occurrences to CNDDB, please. Private landowners can identify their reports as confidential. The polygons that identify the locations can be large to obscure specific locations. I know it takes paperwork because I fill that out and it's a pain in the butt, but the CNDDB is the go-to resource when planning a project, and without that information, we don't know what's out there. And last of all, value wildlife as a vital component in the forest ecosystem. What to stay tuned for? Well, SNAP, the Sierra Nevada Adaptive Management Plan or project, their reports on Fisher and spotted owl are ongoing. They recently got some up-to-date information in online repositories that they can share widely. CAL FIRE reinitiated their vegetative treatment program's programmatic EIR, and it's going to contain a checklist of biological resource considerations with measures to mitigate potential impacts. Fish and Game is in the midst of its third season of collecting data on mesocarnivores, small mammals, and birds throughout the north central region of the Sierra Nevada. They monitor where humans fear to tread since the plots are random and can take you to some pretty intense vegetation. The Sage-Hen Experimental Forest in Nevada County will be implementing forest-level fuels treatments using the recommendations of the GTR 220 and using it as a guide. They have years of research on a long list of ecosystem components that include the American marten, and they plan to track the potential impacts to this species of special concern. And then there's others like Ryan Burnett's work with the Point Reyes Bird Observatory and the Pumice-Lassen Administrative Study. They'll also provide guidance and have provided guidance on projects with wildlife in mind. And you'll hear from Ryan later in the series as well. In the meantime, Other resources that you can utilize to find more information can be found in the California Forest Improvement Programmatic EIR and its accompanying regulations. It isn't very often that we go to those places